So, hey, have you ever thought about protein folding and how it might have something in common with the concept of time, or at least the concept of time in Doctor Who, right? Well, let's kind of think about this. In Doctor Who, at least David Tennant's doctor, he described time as, many people think of time as a linear progression from cause to effect, right? But in fact, David Tennant described time as a massive, wibbly-wobbly, timey-wimey stuff, right? And so what does this have to do with proteins in this case? Well, let's kind of think about that. A protein is a polymer of amino acids, starting from the N terminus to the C terminus, right? And so it's a linear progression from N terminus to C terminus. That's primary protein structure. In fact, however, proteins are actually tertiary structure, and to get the function of a protein, that protein needs to fold into a timey-wimey, wibbly-wobbly enzyme to do its thing. And so when proteins fold, that's driven by the process of entropy, randomness. The hydrophobic amino acids are on the inside of the protein. The hydrophilic amino acids are on the outside. If you think about this like a cable, like your cell phone charging cable, this is a folded protein. This is a folded cell phone charging cable. It's really just like a big plate of spaghetti. And, randomness has caused it to unfold and, to twist and turn and maybe even make a couple of knots. We can make knots like that. So we can take that apart. And ultimately, here's another knot in there that we've folded. And the process of entropy, just the way proteins fold, the process of entropy, randomness, makes your cell phone charging cable, instead of one long linear cable, makes it ultimately fold up into a massive timey-wimey, wibbly-wobbly 3D arrangement. That's entropy. So proteins fold the same way that cell phone charging cables also fold up over time. Now you know.